Ni hao ma, everybody, ni hao ma. Habari yako, habari yako. Isaac, Isaac. Ogenki de suka. Wherever you are in this part, in every part, wherever you are in each part of the globe. Welcome to Paul's tutorialservices.com. Como estas, everybody? Como estas? Ogenki de suka. How are you doing? How are you doing? How is it? How is it? How far? How far? Labas, labas, labas. Welcome back on this Math Lab. Thank God Thursday, Math Lab on this Thank God Thursday. Hope you guys had a good Wednesday. Hope you guys had a good night. Now we want to revisit our take-home assignment. Remember, we were working on the principle of the nth root of a real number, the principle of the nth root of a real number, and now we were also finding out about what a real number is, and we are also exploring the even numbers, and also we are exploring the odd numbers, the even numbers and the odd numbers. So now we had this take-home assignment. Hope you guys got it right. Remember, we want to find the nth root of this. 4 is at the tail. We want to find the nth root of 4, and being at the tail, and 16 under the root. So now this now is equals to, we're going to say this now is equals to 2, all right? And whereas 2 is equals to 2, whereas 2 is equals to 2 raised to the power of 4, whereas 2 is equals to 2 raised to the power of 4, and then once we do that, then we get 16. Get your calculator and calculate. Let us calculate that together, make sure it is right. But now that is the answer for that take-home assignment, because now 2 times 2 give us 4, and then 4 times 2 give us 8, and then 8 times another 2 give us 16. So that is 2 raised to the power of 4. We multiply that 2 and we raise it to the power of 4, so that we get our answer as 16. So now this right here is a real number. This right there becomes the nth root of that 4 at the tail and 16 under the root. So hope you guys got it right. Now, what about this now? We have, what about that? We have 6 at the tail. We had 6 at the tail. And then we also had 64. We also had 64 under the root. We had 64 under the root. Now, to do this, we're going to apply 2. Remember, real numbers are numbers which are divisible by themselves, and also divisible or multiplicable by 2. Real numbers are numbers which are divisible by themselves, and also they are also multiplicable by 2. So when we look at this, they are also even numbers. When you look at them, they are also even numbers. So now we're going to start with the least number that we know. Remember, at the tail is always a 2. So now this now is equals to 2. And now that gives us 2. And now that 2, we're going to raise it to the power of 6. That 2, we're going to raise it to the power of 6. So now, therefore, once we equate that 2 to the power of 6, we're going to get 64. Now, so now that means that 2 is 64. So now you can say 2, whereas 64 is equals to 2 raised to the power of 6. 64 is equals to 2 raised to the power of 6. So now our bottom line, the answer is 2 raised to the power of 6. If you got it right, give yourself a pat at the back. If you got it right, give yourself a pat at the back, and share with your friends. Share with your friends. Click the like button for me if you are enjoying this tutorial so far. Click the like button for me if you are enjoying these tutorials so far. Click the like button on Facebook page, and also remember to watch my short and long videos on these tutorials over my YouTube channels, Paul's tutorialservices.com, coming to you live on this Thank God Thursday, coming to you live on this Thank God Thursday. So now let us erase all this and do our assignment for the day. Let us learn something else for the day and see how we're going to do that. I hope you guys took note of my Cash App sign. You took note of my Cash App sign. Drop something, make a donation, any amount, $1, $2, $5, any one-time donation. Support these tutorial services as God will enable you. Any amount, from any amount as you can. One-time subscription, monthly, one-time, monthly, yearly, any amount will be appreciated so that these tutorial services may continue, So now let us look at, we have 3 at the tail, and then we have 125 under the root. So now we have 3 at the tail, then we have 125 under the root. 3 is at the tail, and then we have 125 under the root. So now this is, we're going to look at the number. So when we look at this look like odd numbers. This look like odd numbers. So now we're going to look at the numbers which are mostly close to 125, and they are divisible by 125. Remember, those numbers whichever number you choose must be able to be equated to the power of 3, since 3 is at the tail. So the number that you choose must be able to be equated to the power of 3. So when we look at this, we see that we can use the number 5. And then that means that we're going to equate this 5, whereas 125 is equals to 5 equated to the power of 3, whereas 105 is equals to 5 equated to the power of 3. 5 equated to the power of 3. So now grab your calculator and make sure it is correct. So now this is the answer right here. 5 equated to the power of 3. So that means that you're going to multiply 5 times 5 to get 25, and then you're going to multiply 25 by another 5 to get 123 So now 5 is the number that we're going to equate to the power of 3. So 5 equated to the power of 3 is the answer to that problem. So now this is how you're going to write it. So now that is how you're going to write it. So now you can also, so now we will put it for your instructor like this. You're going to say, you're going to write it just the way it is like this, and then this would probably be your second step. So this would be your second step. So you're going to put it like that, and then you're going to say is equals to 5. Yeah, you're going to say is equals to 5, and then you're going to say whereas 5 equated to the power of 3 is equals to 125, whereas 5 equated to the power of 3 is equals to 125, is equals to 125. And then now you probably get your 2 marks. You'll get your 2 marks for writing it that way, So now, because we have exhausted the 9th root, we are going to look at, we're going to introduce another topic, having exploited the principle of the 9th, of the nth root, the principle of the nth root of real numbers. We've exhausted them a lot. So now let us look at the simplification of these real numbers. Let us look at how we're going to simplify these real numbers right here at paulstutorialservices.com Facebook page. How are we going to simplify these real numbers right here? So now let us look at something called simplification rules. Let us look at something called simplification rule. So now you want to note that down because you may come across it at your school, at your classwork, and now once you come across it, you know what to do. Once you come across, if you're asked simplify, you have to know. So now from this one now, we are going to learn about the real numbers and the ones which are not real numbers. So now we are going to find out how do we identify what is real and what is not real. So now, for example, we are going to have n is going to be at the tail. So now we're going to have n is at the tail, and then inside the root we're going to have x, and then now we are going to put all this in the bracket. We're going to put all this in bracket, and then we are going to equate them to the power of n. So we put this in bracket, and then we are going to equate this to the power of n. So once we do that, then we're going to look at what are we going to find out. So now when we do this, we found out that this n right here would multiply with that n, or this n right here would cancel. That n would cancel with this n. This n would cancel with this n, and then therefore, because remember why is it canceling? Because there is a bracket. So whenever there's a bracket, we have to find a way of doing away with the bracket. We have to find a way of doing away with the bracket. Yeah, we have to simplify it, hence the simplification rule. So now this n will cancel with this n, and then now we're going to remain with x. Then now we are going to remain with x. So now that means therefore that this whole thing right here is real. This right here is real. That is how we identify the values there are now considered real. The values there are now considered real. So now, this is this right here are examples given in terms of variables. When you look at them, they are all variables. There are no digital numbers there, but there are no numbers except there are no numerical numbers except what we have there are letters or variables. What we have there are letters or variables given to you as examples. So now let us look at one with numbers. Let us look at one with numbers. So now the one with numbers would be something like this. So now we'll have the under the root the number 5. We'll have under the root the number 5, and then in bracket, and then we're going to square it. We have the number root in bracket, and then we're going to square it. We're going to square it. So now when you look at it, where we are going to look at the simplification rule. We are going to look at the simplification rule. And now remember that at the tail is always considered 2. There is an invisible 2 at the tail. So we're going to take that invisible 2. This tail is going to cancel with the number 2. That tail right there is going to cancel with the number 2. And then therefore, just like that we did earlier, we're going to have this now is equals to 5. Get the drip up there. Here it was equals to x, but down here now, because we are using numerical numbers, we are using numerical values, so this now is equals to 5. That right there is equals to 5. The bracket is gone, and the tail has cancelled with the 2. The tail has cancelled with the 2. The tail has cancelled with the 2. So now let us look at another one. Let us look at another one as I raise the board so that we get more space. As I erase the board so that we get more space. So now let us look at another one, and I hope you guys are having fun with these tutorials. Please click the like button, click the follow button if you are new on this page. Invite your friends and subscribe. Invite your friends and subscribe. So now we have 9 is under the root. So now this time we have 9 is under the root. Okay, 9 is under the root, and is squared. 9 is under the root, and it is squared. So when we look at this now, we have to find, now this is a bit different now, because now we have to simplify it further. We have to simplify it further, because now 9 is under the root, and now 9 here is not divisible by 2. 9 is not divisible by 2. So now we have to look to the next number after 2. The next number after 2. So the next number after 2 would be 3. The next number after 2 would be 3. So we're going to put 3 in bracket, and then we're going to equate it to the power of 2. We're going to put 3 in bracket, and then we're going to equate that 3 to the power of 2. And then therefore once we do that, then we're going to end up with 9, whereas 3 equated to the power of 2 is 9, whereas 3 equated to the power of 2 is 9. So therefore these are real numbers. These are real numbers. This right here are real numbers. So now we know that Now we know that if n even uh, even x, so now we know that if n is even and to the numbers given, then it is real number. If n is odd over real is any, real is any. So now you see that these ones are real, these ones are real. The simplification rule. So hope you guys remember how we can simplify all this stuff. You'll always remember how we will be simplifying these stuff as time goes by. When you come across this in your CAT test, you'll figure out how to simplify all this stuff. So now for today, okay, I want to do one more so that when I give you guys an assignment, you will know what to do. You will know what to do. So now, let's write some notes down. So let's write some notes down. So if n even, so now even x, so now if n even x is greater than or equal to, is greater than or equal to, and so now if n or x is greater than or equal to 0, if it is greater than or equal to 0, then that means that n would be considered even number. So the number given would be even. The number given would be even. Okay, so if it is greater than 0, then it will be considered even number, because that means that it is able to be divided by itself or by 2. The number given would be able to be divisible by itself or by 2 or by 2. So that means that it is greater than 0 or equal to 0. It is greater than 0. Basically, it is greater or not less than 0. It is greater than or not less than 0. So that's when the number is considered even. An example would be 4 is under the root. So an example would be 4 is under the root, and it's on bracket. 4 is under the root, and it is on bracket, and then it has been squared to, and then now it is squared to the power of 2. It is squared to the power of 2. Then we find that is 11. It is squared to the power of 2. Then we find that it is 11. We find that it is 11. So that is an example. So that is an example of how an even number would look like. That is an example of how an even number would look like. So now, what about if the number is odd? If the number is odd, so n odd x over real is any number. So now they put the notes, you can put a note there if the number is odd. So if n odd is x is any real number is in the system. So now if n is odd, then x would be over over any real number. It will be over any number in the in the system. N would be over any real number in the system. That is when the number is odd. When the number is odd, then N would be any real number in the system. N would be any even, I mean, if N is odd, X would be any real number in the system. X would be any real number in the system. Paul's Tutorial Services.com coming to you this Thursday. Thank God Thursday, MATLAB. Thank God Thursday. All I have is Jesus in my life. I heard that song earlier. Thank God Thursday. All I have is Jesus in my life. Thank God Thursday. All I have is Jesus in my life. So make sure you are enjoying these tutorials. Make sure you are interacting with these tutorials. Please click like and share. Click the like and also click the share button so that your friends may enjoy these tutorials and benefit from this tutorial. Interact, bring your children to learn some mathematics and learn some other subjects, and also support these tutorials. Use Cash App, use Zelle, use any means possible to support these tutorials. Subscribe. I can't emphasize enough. Subscribe. Watch my YouTube channels. Subscribe, and also register for tuition at Paul's 101 tutorialservices.com, and God will bless you, and God will bless you. Thank you very much for watching. Click the like button for me. Interact, send me a message, write a comment down below, and God will bless you. Bye-bye. Enjoy your day, enjoy your afternoon till we meet again.